Howdy all. I think we should be up and running now. Give me just a minute. We'll get a few things ready and kick off. How is everyone? Or how are we? Are we all? Yeah, look, just looking at chat, I've missed these sessions too. I was off for a week or so, a little over a week, knocked out pretty crook. And then things were just a bit flat out. So yeah, it's been a little bit quiet on the stream front, but I do hope to get back into these pretty quickly. I like the sort of pace of doing them one a week. Alright, we'll get going in just a tick. Can you guys hear me at all? Just want to make sure that everything's working. Cool. Okay, let's go. And chat box is not working again. I don't understand what's going on there. Exactly right. The coffee does not drink itself. It needs to be drunk. All right, so let's fire things off. I'm not sure if chat's going to catch up or what, but we'll see what's going on there. All right, so Speedy Knock. About a year ago, I did a little video showing off just I guess a technical demo of a product I was putting together for knock control. And the reason I did that was, well, the reason I put something together is because when I went looking to find a decent standalone knock controller, I didn't find one. And or there are a couple of really good ones out there, but they start at sort of $600-700. They're not hobbyist level things. They're very expensive. They're very nice, but they're pretty expensive. You know, they're 3 times the cost of a Speeduino ECU. And they're not that complex in terms of what they do, although there are a lot of sort of DIY ones out there that, in my opinion, are basically just a random noise detector. I don't think they work particularly well. So I wanted to do one that was actually clever, actually doing things properly, but also wasn't going to cost an arm and a leg. And I threw together this technical demo, and I threw together some code, and I put a video up, and a lot of people got very excited, which is fair enough. I got very excited too, but then it sort of sat for the best part of 12 months, really, and other Speeduino related things got in the way, and I haven't really come back to it. But as everyone who's watched these streams will know for a little bit, it's sort of a running joke that, excuse me for a minute, that someone will always ask about Speedy Knock on one of these videos, along with Drop Bear these days. So finally I dusted it off about a week ago, and started actually playing with it again, and refreshed myself on what the hell the code base was doing, and where it needs to get to in order to be ready for release. So I've got grand plans of putting some hardware together that will fit in a nice 52mm gauge pod housing, and I've got got these pod shells that I'm working with to try and get a design on. They're mostly a nice design, in that they're at a standard size and will let me do USB output and things on the back, so that's all cool. But actually designing, pardon me, actually designing the hardware to fit in those is quite an effort. So I think what I'm going to do initially, at least, is throw together a sort of DIY type board. I'll sell them fully assembled, but they're not going to be in a nice fancy gauge pod housing or anything. They'll just come together in some sort of little DIY hobby box, at least to get these out into the hands of people, so we can all start having a bit of a play with them. And obviously the code and everything's going to evolve over time. So I'll do these as, I guess, a bit of a beta run. And that's sort of what I'm going to be running through today. This is a seriously in development system. So anything I'm going to run through and show you today, keep in mind that this is not, I'm about to release this next week, and this is what it looks like, because it looks like crap at the moment. A lot of this is very, very much a work in progress. But I thought I'd show you sort of where it's at, what it looks like, and basically doing one of my normal live codings where I just sit here and code away and adding some features. So, if the streaming gods are with me today, I should be able to do that. Okay, this is one of the early designs that I've got beside me on the bench. Apologies for the abysmal quality of the camera that's running it. When I decided I was going to put up a demo beside me on the desk, I went fishing for another webcam and only had some ancient old thing hanging around. But hopefully it will give you at least an idea of what's going on as I work through this stuff. In the mode it's on at the moment, it's showing the knock detected line down the bottom and a knock threshold up the top. So this is, if we move the RPM around a little bit, it's hooked up to a stim at the moment. We can see that threshold line changing, and that's based on the thresholds that are set per RPM. Now there isn't actually a sensor attached to this at the moment, so that the actual signal reading is little better than noise. So it does jump around a little bit. It can pretty much be ignored for the moment though, because there isn't a sensor attached. And there's a frames per second counter there as well. Now I will warn you that when mucking about, I accidentally killed a couple of rows on this OLED display. So if you look at the top of it, it won't be right. Some of these screens have text on them up the top, which won't come through clearly. But I've got another few screens on the way to fix that up. But silly me in my testing earlier this week did that. Okay. Okay, so the other side of the whole SpeedyKnock piece, I suppose, is the desktop software that it will come with. Now this is seriously early days, but let me just fire it up for now. For anyone who's used Speedy Loader or looked at the new RGStim, this will look really familiar because I'm basically using the same sort of template on it. This is not what it's going to look like final wise color in terms of color and layout and everything. It's just to get something up and running. So pretty obviously we can connect to the board, and we've got a live representation of the data that it's reading at the moment. Now this is essentially showing the same thing on the PC that we're getting on the OLED display at the moment. So likewise we can adjust the RPM, which will adjust the threshold line, which in this case is the red dotted one. We can see that go down, or we should see it go down, yep, and come up again as well. There's a bit of a difference in the axis between the OLED and the software, but that's all right. Pretty minor things in the scheme of it. So that's a simple view of the live data. There will be a view of the calibration thresholds. This isn't working currently, so this will be where you can modify what you want your thresholds to be for any given RPM level. This one needs a lot of work. I won't have that ready to go for a little while, but that's what that will look like. That'll have a few more points. Obviously that's only got the 2 points along there at the moment, but it'll have probably 16, I think, points is what I'm going to aim for. So what sensors are recommended to work with SpeedyKnock? Yeah, that's a really good question, Connor. I forgot to mention that these work with the standard Bosch donut type sensor. So that the non-frequency specific sensors, which are generally the most common ones, and are certainly the easiest defined, in my opinion, and are the easiest to install in a generic sense. They're not designed for a specific block or tuned to a specific frequency. They're simply open in that sense, so they're pretty flexible. And they're a simple 2-wire sensor, nothing complex at all. And there'll be a config screen here, and this is partially what I'm going to be working on today, I think. All of the values that are here are not communicated back to the board yet. This is simply me doing a bit of a layout for what the sensors, for what the settings are that we're going to need. And it's pretty basic stuff. It's, number of cylinders, ignition signal type. So we need to know these two pieces of information because the board takes, like I said, an RPM input, which is this one here. This one here. Yep. To be able to do a couple of different things. One of my biggest gripes with some of the knock sensors that were on the market, or knock monitors that were on the market, the really basic ones out there, was that they're not doing anything fancy as far as signal processing goes. They're just watching for a certain threshold and triggering a knock event should it detect that. Now the problem with that is that the knock threshold moves with RPM. At low RPM, you'll have a lower knock threshold than what you'll have at 5,000 RPM or 6,000 RPM. That's just the way these sensors work. And if you watch one of these sensors, or if you watch the previous video, and I can link that below, you can see that the knock level will rise as the RPM rises. And sorry, that's just the knock reading level, where there's no knock actually occurring. So you have to be able to take RPM into account. In the case of Speedy Knock, all it does is take a feed in from the Ignition 1 output from the Speeduino. So the Ignition 1 signal that you would feed through to your Ignition 1 coil or to your distributor or your first pair of coils in a wasted spark setup will be fed also through to Speedy Knock, and that's what gives it its RPM calculation. Now to do that, we need to be able to know the number of cylinders and whether the ignition is running sequential, wasted spark, or in a distributor mode. What this also does is allow us to have a reference for when spark is occurring on cylinder number 1. When we know that, we can do proper knock windowing, which is what these settings down here are for. So we're saying that knock will only occur for a set window after an ignition event occurs. So it won't just happen any old random time. You'll have a spark happen on one of the cylinders, and then there'll be a window after that spark happens that knock can potentially happen in. In this case, I've set it up with some fairly typical values to say I want that window to be 40 degrees long. So I don't want it based on absolute time. I want it to be based on RPM, which is much more realistic because the speed of when that knock will happen is based on piston speed. And there'll also be a little bit of a delay. So the knock window, or the window for knock potentially starting, doesn't happen immediately after spark. It happens about 5 to 10 degrees after spark. So we've got those two settings. And again, we need to know the RPM and we need to know when the spark is happening in order to be able to calculate that. Now, we've only got one ignition signal coming in here, but if we know how many cylinders they are and we know the ignition signal type, and we also feed it the firing order, and ignore the fact that this is obviously pretty ugly in the UI at the moment. If we know these three pieces of information, not only can we determine when the spark is going to happen and monitor the knock for it, but we can also know that if we do see knock, we can calculate which cylinder it's going to have happened on. Obviously, in the case of a distributor setup or a wasted spark setup, we can't fully determine what the cylinder is going to be. We can nail it down to a pair of cylinders in a wasted spark setup, or in a sequential setup, we can obviously nail it down to which actual cylinder the spark will be occurring Do I have a pick or part number for the Bosch sensors? That's a really good question. I don't, but they're really easy to find. Donut knock sensor. I could certainly get the part numbers. Actually, let's just look at here. Yeah, it's this style of sensor here. Really, really basic sensor. Not that style, if that's one of them. One of the other, the frequency locked ones. So yeah, really simple. Basically, you just attach them to your block in the right location, or roughly the right location. Bolt them in, and you're good to go. Very, very simple setup. All right, so in terms of the other settings here, we've got, we need to know the rough frequency. So I said these sensors aren't locked to a given frequency, which is correct. How we manage the frequency instead, because the knock resonant frequency is different for every block, we do that by setting up the knock amplifier that's on this board, this little chip here, with a certain frequency. And that frequency we can calculate based on the bore size of the block, or we can just enter it in manually. Now again, none of these settings are actually getting fed back to the board yet. That's probably something I'm going to work on today. But we do need to know that information to know what frequency of knock we're going to be looking for. And finally, we've got the calibration settings here. So the board has an auto calibration routine on it. So basically you set your ECU with some very, very conservative timing. Set it to 10 or 12 degrees or something. A level of timing that you know for sure is not going to knock. You can bring the engine to an idle and you start the calibration routine, and I'll show you what that looks like in a little bit. Then rev the engine up to this max RPM figure, whatever it happens to be. And as you do that, the board will detect what the knock sensor readings are, add a threshold amount on top of the readings, and that will give you a nice standard running knock threshold curve. So you know that anything under that is not knock. Whatever those readings happen to be will not be knock. They're just normal noise from the sensor. Conversely, anything then that you get above that level can be considered knock. Generally, you watch for a couple of different pulses above that level in a row or in a short space of time to be considered knock. But that's generally what we get the ECU to do. Okay, so all of that said, we've got the basics of a UI here. It's pretty rough, but it's starting to come together. Some of this is implemented in the code and some of it's not. And that's really where we need to work through today and over the next coming weeks. It's really early days on this, guys. I do want to stress that. A lot of the things I've talked about aren't yet written in the firmware. They're not yet supported in terms of communication back between the board itself and the software. Some of it is. Some of it, like the live readings, obviously is working. But all of the config stuff and the threshold setting very much isn't at the moment. So that's what I need to work through. But do keep in mind that it's really, really early days on this at the moment in terms of the feature support. Where I want to get to is tidying up all of the firmware and software work within the next month, and then moving to a beta after that. I'll have a quick look around and see what I can find in terms of a nice little case to put this in. The biggest issue with the case is really having a cutout for the OLED. It's not a big OLED, but you do need to be able to have some sort of cutout for it. And that's where I haven't found much in the way of good enclosures. So look, it might be something as simple as a 3D printed case for now. Who knows? We'll wait and see. All right, so I'll reset that just to disconnect the board. And I'll start working through a couple of things here. what I'd like to work through today is getting the config settings that I showed actually fed back into the board. They don't have to do anything yet, but I want the two to be talking at this stage. What I've got in the code is an outline for the settings, so a struct of what that's going to look like. Basically the same things we were just looking at: number of cylinders, pulses per cylinder, which is what we're looking at in terms of sequential, distributed, or wasted spark. Minimum and max RPM for the calibrations, the knock window duration, the delay, and the calibration threshold. What I might just work through today then is getting that information dumped back into the board from the UI. And I don't think it's going to be too difficult. Well, yeah, I've gone and said that now, probably will be. The comms between the board and the UI is a little bit finicky. The UI is written in, an Electron application, which is all JavaScript based, and the serial comms to JavaScript can be a little bit interesting. It's not the ideal way of doing it, in my opinion, but we'll work through it. The code for this is not yet available. No, I'm going to hold on to it. It's not ready to go yet. It will certainly be released when all the hardware and everything's ready to go, though. All right. In terms of how the comms works, there's three commands that we can use: the get commands, set commands, and config commands. So the get commands is just retrieving the data off the board. Now, in this case, it's a G1 command, which will simply fetch two things. It'll get the current knock reading and the current knock threshold, which is what we saw being displayed on that live graph. There'll also be a get, for example, for RPM versus knock reading. So you can see a nice chart of knock versus RPM as well. But what we're going to be more worried about here is C commands, which are going to be the config ones. What I might just do is show quickly what things like the calibration mode looks like. You can see here that just for testing, I've set the mode into the pre-calibrate screen initially. So when this boots up, it will go into its pre-calibrate mode, which does a sort of, well, let's have a look. Let me just reset it. Okay, so it'll boot up and it'll say, okay, calibration is about to start in 5 seconds, and it'll do a quick countdown. And in fact, I think I've just got it dumping back to the main screen here. Let me look. Okay, of course. So that's sorry. I take it back. This is showing the calibration screen at the moment, hence why that's actually just showing an RPM reading, not a knock threshold reading. Okay, that makes more sense. I should have thought about that. So the chart, the line that you see here going up and down, if I actually do that properly, you can see that going up and down. That's simply the RPM reading. So if this was doing a calibration, your RPM would be right down here at idle, and say, okay, slowly increase your RPM until it reaches the maximum. So you just give it a bit of a rev, and that would lift up. And during the calibration, it would be taking the knock readings throughout this time, and then applying those to what the threshold value should be. Are you going to show us how to use Speedy Knock with Speeduino? That's a good question. I hadn't thought about it, but I potentially can. Yeah, let's have a look at that. I'm going to just have to do. That's actually a really good question, Connor. So it's how is this going to interface with TunerStudio? Yeah, am I going to put a sound alarm on that? Yeah, I am. You can see that there's actually a mode here for display alarm, which if it detects knock, basically the screen just flashes white and black, and there will be a buzzer to go along with it. I can certainly add an LED. I'll probably add an output as well, so you can actually hook it up to your own external LED. Aaron, have you given much thought to adding the back-end TPIC code? The TPIC is the knock amplifier chip. That's this one here. Into Speeduino. I have, and I'm not going to do it. There's a couple of reasons why, but in my opinion, this is better serviced on an external chip, at least in Speeduino's case. Really good question about showing what it looks like in TunerStudio. I will show that because it's interesting. I'm going to have to make a quick change just to the INI file to show to get these showing. So give me just a minute. So hopefully that gives you a bit of an overview of, at least, of what Speeduino is. I hadn't quite intended to waffle on for 25 minutes about it, but that's all right. We'll get into coding at some point, no doubt. Okay, let's fire that up. Now, before the knock things are going to be visible, I'll just need to make a quick change on the INI file is all. Okay, so here's the INI file. So all the knock settings have been actually built into the INI file for quite some time, and they're actually sitting in the memory config on Speeduino firmware at the moment. But they're completely inactive. They're not doing anything at all. Where do I need to do this? Okay, so I'm just going to enable that dialog there. Reload the INI file. Helps to save that first. I haven't actually looked at this for quite some time, so hopefully this all does work. No. Well, there you go. Or did I put it under here? Knock settings. There it is, under the Spark menu. Shows you how long it's been since I've looked at that. I couldn't even remember where I put it. Okay. So here's what I originally set up for how this would look. Some of this will now end up in the config for the Speedy Knock. You can see the knock window and the knock duration. This will all be handled by Speedy Knock, so it won't actually be part of the firmware at all, but will be. So I'll pull all this out. But the settings up the top is what we do need. Speedy Knock will probably have two different interfaces out to the ECU. It'll have an analog one and a digital one, with the digital one being preferred. So the digital one will simply give a pulse when knock is detected, and multiple knocks for every knock event that comes through. So in this case, we'll say it's going to be a digital setting, whatever the knock pin happens to be, knock active when pin is low or high. I'll config that later, whichever way it happens to be, and whether we need to pull up resistor on it or not. The answer is probably going to be no for most of that. These settings here, though, are the ones we really need to worry about. So we're going to say, okay, how many knock events do we need to see for it to be considered knock? And we're going to say, okay, we need 3 events, and this is within a single. I think the threshold is 5 RPM or something like that. The maximum RPM and the maximum KPA for readings. Now, this is because knock tends to be not unreliable at higher RPMs, but much more difficult to accurately read. Hopefully a lot of this stuff will be able to be tuned with Speedy Knock itself, so that we can go to higher RPM. But if you're using a different aftermarket Knox controller that doesn't work well at high RPM, you can filter these out. This section here deals with what's actually going to happen when we're in knock mode. We can say what the total ignition retardation will be, but it won't immediately retard by 15 degrees. It will go there in steps. So the first step, we can say, okay, maybe straight off the bat, as soon as we get knock, we're going to retard by 5 degrees. And then for every step time, in this case 2 seconds, so every 2 seconds, if we're still getting knock, we're going to retard by a further 1 degree, up to a maximum of 15 in this case. And again, all of these are obviously settable. So 2 seconds is probably a bit high. You'd probably want to be looking at, say, half a second there. So every half a second, if we're still getting knock through. Oh, Edson, thank you so much for the donation. I really appreciate that, man. I should say on here that you don't have to donate by any means. It all goes back to the project, which is terrific, but I really just do the streams for people's enjoyment, and hopefully people get a bit out of them. But I really do appreciate anything that does come through. So that's the action that we're going to take whilst knocking is occurring. And then we're going to have a recovery section as well. So this is basically how quickly, once the knocking stops, we get back to our regular ignition running. So we've got our step size. We're not immediately going to go back to full ignition. We're going to slowly step back based on a certain step size, and what the time for each of those steps is. Right, so that's sort of what it's going to look like within Speeduino. Some of these settings I might retain to work with other knock controllers other than SpeedyKnock, but in SpeedyKnock's case, certainly these functions here, the knock windowing and the knock window duration, are going to be handled in the controller itself. Oh, so what's the communication between SpeedyKnock and Speeduino? It's a simple one-wire digital pulse is the most likely answer there, Connor. So it's simply going to be a pulse output from the SpeedyKnock every time a knock event occurs. And then the Speeduino itself can decide how many of those knock events it wants to see in a certain amount of time before it takes action, and then how it's going to respond to that. There might, as I said, there might be an analog value as well, but I don't think analog's the better way to go. I think it's that is leaving the job of determining knock up to the ECU when we've got a controller there for doing it, and the controller is cleverer and more focused on being able to calculate when knock is occurring than I think the ECU is. At least that's the design that I'm going for with SpeedyKnock. So a simple digital pulse to say, yep, knock, knock, knock. If you get 2 or 3 of those in a short amount of time, you probably want to start taking action on it. One of those, well, might just be a little bit of noise that SpeedyKnock didn't detect, but it might otherwise just be, but it might be something that you want to take action on for a single event, or not. Okay, does that all make sense? Feel free to fire any questions in if it doesn't. Again, my apologies for the chat not working. I don't know what's going on there lately. It had all been working fine, and then it seems to have just stopped recently. So I don't quite know what's happening there. Just have a quick look at it, make sure it should be turned on and everything. I have a look at the settings and then it all pops in. That's terrific. Don't know what's going on with the chat there, sorry. So apologies there, guys, but it looks like it's coming through now. Okay, the one thing I actually haven't shown is the actual knock screen itself on here. I just realized. So what I'm going to do is I'm going to just comment out these lines, which are purely here for testing. It just forces the board into the pre-calibrate mode. And I'm just going to upload that. Now, unfortunately, there's no auto reset on this board at the moment. I've got to do a manual reset. So apologies for my big ugly hand being in the way. Give it just a second to compile. Okay, so that should reboot, and it should be, yeah, okay, now we're in proper knock mode here. So this is the standard screen that you'll see when the board is just running in normal mode. We've got the RPM reading, the current knock reading value, and the current threshold. Ignore the FPS counter down the bottom, by the way. That's just a debug thing. That'll get turned off later in the development cycle. Again, apologies for the couple of dead pixels at the top here, a couple of dead rows. So again, if we twiddle with the RPM here, we should be able to see the threshold itself changing. And you can probably see the knock reading down the bottom moving a little bit. Like I said, there's no actual sensor attached here, so it's kind of just a little bit of random noise that's going on. But you can see it moving a little bit, which is what we saw on the display in the UI as well. Okay, so kind of, is it a stupid question to ask for an audio out on SpeedyKnock? No, and that will be there as well. So basically, to just, it'll have a small amplifier circuit as well, just to plug in a set of headphones, so you can listen for knock as well in tuning. Keep in mind that SpeedyKnock is designed to be used, yes, during tuning, but given it's a standalone system, it's designed to be there all the time. You wire it in and you just leave it. That way, you can be monitoring knock, and it can be looking out for knock based on, you might get a dodgy batch of fuel or something like that. So it is designed to be there all the time, not just during the tuning phase. Okay, so in terms of the comms, or does anyone else have anything, by the way, just about the general functioning of what it is, what it's doing, how it works, before I start really sitting down and knocking out some code here? I guess that's probably the demo part of the talk today, and the rest is going to be me just hacking away on it, I suppose. If not, I'll probably crack into it, unless anyone has anything else they want to know. There is two sides to the development, obviously. Here we've got to work through the UI side and the firmware side. Unfortunately, it's not quite as neat as with something like TunerStudio, but that's the price we pay for our own standalone applications, I guess. What's the difference of this compared to a normal ECU with a knock sensor? Okay, it depends what that ECU happens to be doing. There is a real difference between the bottom end of the knock detection market and the top end. Somebody mentioned the Plex units before. The Plex, in my opinion, are the gold standard. That they are really, really fantastic little units, but they're sort of $700 or something. And they do all of this stuff properly. Different ECUs, if they're taking a raw value straight from, or they're taking a knock sensor feed directly, then what they're actually doing with that signal, it varies a lot. Some of them, like I said, are not doing any knock windowing properly. They're not doing variable knock thresholds with different RPM. And if you don't have that, the signal that you're getting as an output and what you're doing with it varies dramatically, and it can be real garbage in some setups. So that there's no one simple answer to that. What's a normal ECU with a knock sensor doing? Who knows? It depends on the ECU. Some do it much better than others.
Any ideas?
All right, so I'm going to implement a couple of commands here. Just going to copy this chunk of code because we need to use the same thing. So all we're doing here is we're getting a command from the UI. The command is C, and that will have a number following it. C1, C2, C3, C4, depending on what we happen to be doing. We will implement, say, a C1 command. So we look for the next character. We just say, okay, if there's nothing else in the serial buffer, we just sit here and wait for a second until the next character comes through. We read what the command number is going to be off the serial buffer, and we take action accordingly. So the C1 command is going to be, it's going to be a couple of, okay, so C1. C1 is going to be, I've got to remember how I had the command structure laid out in my head. C1 is going to be send the current firmware version. So this is a way of the UI determining what firmware is on the board that it's talking to. And it's going to be a single byte returned for the firmware version. Now in this case it's all just version 1. We've got nothing else happening there. So that's a dead easy command to implement. The C1. Also not particularly useful and not particularly exciting. C2 is going to be a request to determine how, or for the UI to know how big the config size is. And we're simply going to return the size of the config struct. I think it's called config. Let me check. Yep. So we define this struct here with all of our settings in it, and we call that struct config pretty simply. And that command then is just going to return the size of that. Now we need to know the size of it on the UI because the next command is going to be the most interesting one here, which will be to request the config. So the UI will then, it'll do all of these in sequence. It'll issue the C1 command to know the firmware version, the C2 command to know how big the actual config is, and then it'll issue C3 to get the config itself. And it needs to know the size of the config first to know how many bytes it has to read once it issues the next command, the C3 command. So that's why we have to go through these, jump through these little hoops. Is Speedy Knock powered by USB or plain battery power? It'll be via battery power. So this demo unit here has no power regulator or anything on it because it was just for me to play with. The beta version and the production version that's actually meant to go into a car will all have a 12 volt regulator on it. So it'll just be fed off switch 12 volt power. Have I looked at Harlan Castle's voiding warranties work on knock detection? I haven't, no. I'll take a look though, Connor. Sounds interesting. Anything with the phrase voiding warranties on it is always interesting. Ooh, interesting question. Is there any way to have this expand the digital interrupt inputs? I'm using the knock input for VSS, and I'd like to have both if possible. Interesting question. Probably not. There are a few different or a few spare digital interrupt enabled pins on the Mega, not just the VSS one that's spare. So you should still be able to run VSS and Knock on a Mega board, on a Mega based board. You might be limited on other things though. You can only have so many interrupt based pins is all. So you might not be able to run, for example, Knock, VSS and Flex input on a Mega based board. On a Teensy based board, you'll be able to run as many as you like. What's inside the hardware? Oh, look, it's pretty dead simple. There's not a lot going on here. Let me look. I can cheat and do this, I think. Oh no, I grabbed the wrong one. Let me blow this up for you a little bit. Again, my sincere apologies for the camera, for the quality of the camera here. Okay, that looks a little bit better. So what's going on? Look, it's a pretty simple board. We've got the USB side of things here, and the knock circuit itself is this one here, with the TPIC. Now, what you can't see, at the moment is what's underneath the screen. Let me just cheat for a bit. Okay, as you can see, there's not much to it. There's an AVR chip under there, an 18 Mega 32U from memory, but there's not a lot to it. It's a pretty simple one. You've got a header here for programming the bootloader onto the board, and your inputs and outputs over here, and a little bit of filtering and those sorts of things. But it's pretty basic. There's not a lot to it. Add a voltage regulator on it. A couple of output circuits for the production unit, and you're pretty much ready to go. It's not a hugely complex bit of kit. So all of the grunt work here is being done by the Mega for reading the values here and displaying to the OLED screen, and the Knock amplifier circuit over here for doing the DSPs type things. In. So this TPIC is compiled with the Arduino IDE. The interface between the Knock amplifier and the Arduino itself is via SPI communication. If you have a look in this code, there's just a series of commands that are written up for how to interface with that chip. So these are just a few of the commands that the chip uses. It's not a complex chip to use at all. It's just basic SPI and a few commands to work with it. Oh, now it's worth calling out, by the way, that it's this is a dual channel system. It can take in 2 knock readings, and obviously handle them both. So the idea here is that you can have knock sensors on 2 banks if you've got a V engine, and measure those separately. So that is also possible. All of the firmware and everything support at the moment is all based around a single sensor, but it will have the capability to do dual knock. I really do only plan on selling these as fully assembled units. I try to steer that way for all of the surface mount boards that I do, simply because I think DIY for most people of surface mount is a step too far. Now, obviously, there's an awful lot of you out there for whom surface mount at home is not a problem at all. But for most people, I think it's probably something that's better left alone. So even for the beta, I'll be selling these as fully assembled. The price is a really interesting one. Look, gut feeling is probably going to be around the 150 mark, I suspect. But it's all going to come down to casing and that sort of thing. The beta might be a bit cheaper if it's just a raw board, or if it's just a populated board with a screen on it. It all comes down to enclosures and things. They can be quite expensive, believe it or not. Some interesting questions there. Is it compatible with the Renesas engine? It should be. I'll show my ignorance here and say I have no idea how or what any of the special considerations are for knock on a rotary engine. If there's a few special things that you have to take into account on a rotary, I can certainly do that, but I haven't yet. But honestly, I don't know. I don't know if there's anything that a rotary needs to do differently in terms of knock detection. Will the dev kits allow for an FPGA expansion? Ooh, probably not. I mean, you could add it if you wanted, but there's no real need, in my opinion, to have an FPGA on there, and it would only add to the cost and complexity. FPGAs are wonderful things, but complexity just goes through the roof when you need to add them. You've got to consider how you're going to update firmware and things on them. They're great. I love what an FPGA can do. They're just in a consumer-facing environment where you're wanting to do regular firmware updates and capability adds and those sorts of things. I think they just get tricky. Not impossible by any means, but you know, the aim of Speeduino and all the products I do is to keep it simple, and keeping it simple means keeping it cheap. So. Yeah, what's the chipset? So the chipset is the 18 Mega 32U4, I think. I can't remember. Oh, there it is right in front of me. Yeah, 18 Mega 32U4 is the actual microcontroller on it that I was using. And then the knock amplifier is a TPIC 8101. So TPIC 8101. And it does all the DSP type functions. All right, so going back to the config sent here, we've got these two commands sent. Now the command 3 is just going to send the whole config struct. So fairly simple here. We're just going to run through a for loop that's going to send all the values of the struct. And the way we do that is by creating a pointer to it. Now I'm going to cheat and I'm going to grab some Speeduino code just to make it faster here. Because otherwise mucking about with pointers on a live stream is going to achieve two things. It's going to be slow and boring, and it's going to make me look dumb. So bear with me just a moment. Yeah, the whole reconfigurable computing, I agree. It's too many devices out there are created, with a single use, and they're never upgraded again, despite the fact that they've got a whole ton of capability that's never ever going to get used, or hardware capability. And manufacturers just release them, make their profit off it and move on to another device that they can sell to make more money. And I really hate that. I'm like yourself. I think I'm all about creating something that can be upgraded and used to the absolute max of its ability. Going to drop a few things in here now. When can we buy a beta version? That's a really good question. I hate trying to make estimates on it because I'm really bad and it always takes longer than I think it will. I would hope that a beta will be out by the end of the year. Yes. If not, it'll be early next year. Hardware-wise, there's not much to do. You know, if I'm not aiming to put it into a certain case and I don't need to do 2 or 3 different hardware revisions to get it fitting perfectly and all those sorts of things, then I can probably get it out fairly quickly in terms of the hardware. I probably need 3 or 4 weeks just banging away on this software to figure out what's going on in terms of or getting things up to the right level of usefulness. Okay, so all this is going to do is say we're going to grab a pointer to the config page. We're going to loop through the entire size of the config page here. We're going to read each byte out from the config page. So the reason I do this is because it means it doesn't matter what you're sticking in here. They can be anything. They can be 8-bit values or 16-bit values, or they can be arrays. All this is going to do is read through and just send them out as raw bytes. It'll be up to the UI software to have an equivalent of what this struct is, so it knows how to deal with those bytes. But this is just a cheap and nasty, or a simple way to flick all those bytes through fairly quickly. Be a nice Christmas gift. Oh, it would be a nice Christmas gift, actually. Give all your mates the gift of Knock this Christmas. Now the corresponding command that we're going to have here, or sorry, the next command that we're going to have here will be the C4 command, somewhat ominously, which is going to be to cover off receive full config. And we'll probably have another command down here for just receiving a single byte of config, although we might make that one of the S commands. We'll probably, in fact, we will make that one of the S commands, and we might even move that 4. But that's all right. That's a problem to worry about a little bit later. Okay, if we look at the UI code here. We've got a bunch of serial code that does, it lists the serial ports, and I'm starting to work on adding some detection here, so we can say we can detect an Arduino Mega, we can detect a Teensy based on the vendor ID, the USB vendor ID. Unfortunately, a lot of these a lot of these chips are just generic Arduino ones, and you can't actually detect which specific chip it is, which is a little bit unfortunate, but that's all right. Okay, so here we are, request config. So the function is written here to request it, but it doesn't really do anything. So we can see that we're going to create a parser. We'll actually change the parser there. We're going to send a message to the log, just to the log, saying requesting config from controller, and we're going to do. Let's just launch straight into the C3 command here. We'll worry about all the firmware version and stuff a little bit later. So we'll send this C3 command, which is what we just wrote, and the parser is going to wait for some data to come in. In this case, it's a read line, but we're actually going to change it to be. Should have a byte parser here somewhere. Yep. Sorry, I'm jumping around a little bit here, but let me just show you what's going on. Okay, when we do serial from JavaScript, we create these things called parsers, which are going to monitor the serial receive buffer, so what's being received from the Arduino, and it's going to wait for certain things to happen. And when those things happen, it'll fire a callback to another function. And if anybody mocks my JavaScript for not using things like Lambda functions, they'll get muted, because I hate JavaScript. I really hate it. But it's what I'm stuck with on the GUI side, I'm afraid. So some of these we want to wait for a new line. So we're just going to read one line at a time of data, and that's useful for when we're streaming the live data through. But it's not what we want to use here. We want to have a parser that's waiting for a certain byte length to come through. Now, ultimately, we're going to want to wait for the number of bytes that were sent using the C2 command. So we'll issue the C2 command first. We'll read how many bytes the config is in size, and then we'll wait for that many bytes to come through. In this case, it's going to be, because we don't have all that implemented yet, what, 1, 2, another 8, so 10 bytes, 2 each for these, so that's 14, 15, 16, 17. So the whole thing should be 17 bytes long. Just at a quick count there. So all we're going to do is say the serial library that we're using will wait until it sees 17 bytes on the serial buffer after issuing the C3 command. When it sees 17 bytes there, it'll fire this receive config line, and we'll get config received from controller. Now, just as a testing point and to demo it, what we'll do is simply say we're just going to read it out and dump it on the console for the moment. I think it's probably an easy way to do it. How do we want to do it? Okay, let's do a little bit more neatly though. Let's have some variables, and we'll start chucking them in. We have to reproduce this model in JavaScript as well. Now I'll do it a little bit neater when I clean all this up, but for the moment, let's just do it like this. So the first byte of data that's going to get sent is the number of cylinders. We know it's just an 8-bit value. The second is going to be the pulses per cylinder. In fact, I'm just going to copy that for the sake of simplicity. Makes me want to have an auto engine around to play around with. Yeah, I feel the same about rotary engines, to be honest. I feel I need to get one sitting on an engine stand just to play with all the time. fact, we should be getting a bit more clever about this, and we should be actually updating the values that are in the. If you remember, when we ran the UI, let me fire it back up again. Oh, I've already got it running even. What we're doing is reading this config in so we can populate these values here on the config page. So we actually might as well just be launching straight in and populating them already. Now, these are all just defined in a HTML file. Which is here. Okay, so we can see this is the config settings. And we can see that all of these exist already. Where are we? Okay, so there's the input there. That really should have an ID rather than a name. Okay, for the sake of demo, let's jump in here, and we're going to see if all of this works live as we're doing it. What I'm going to do is just add a testing line in here for end cylinders. We're going to make end cylinders equal 16 because who doesn't love a 16 cylinder engine? And in the serial code, instead of just writing this to a dumb variable, we are going to actually update the field, because why wouldn't we? And sorry guys, I do tend to get a little bit quieter when I'm coding, just because it takes a little bit of concentration sometimes. Okay, so I'm just thinking through if there's anything I've missed here. I have a switch on the board. Are you referring to this button here, the blue button? That's simply a reset button, because there's no, or that the auto reset on this thing doesn't work currently. I've got to tweak that in the firmware and possibly a little bit in the hardware as well. I need a button to manually reset it when I load new firmwares on. Okay, let's see if this is going to work. We'll upload the new firmware. I got no idea if any of this is going to work straight off the bat, but let's see. And again, apologies for my hand. I'll have to do that manual reset. We've got a bunch of warnings there. We didn't put a break in here. That's okay. Yeah, okay, I think that should be all right. That's basically saying that should get declared outside of the switch statement. But I think all of that should still work. I'm just going to drop in another console command here. Oh, JavaScript uses pluses, doesn't it? Okay. All right, if any of this works straight up, it will be nothing short of a minor miracle. But let's connect and see what happens. Okay, we're actually bombing out and not connecting at all there by the looks. Let's just have a look at the console here. Okay, so it's requested the config from controller, but never got a callback here. So either we counted the wrong number of bytes, or it's not sending anything at all. See, it's okay. Well, let's just change that to 1. So we're only expecting to see a single byte of data back. Let's get rid of those. We'll try again. So I guess, guys, that's probably it's a good time to just call out that that's probably the end of the formal side of the stream. I'm just going to be sitting here hacking away, I guess, for a little while now, as long as people are interested. If you've got any questions, now's probably a really good time to ask. Otherwise, I'll just sort of be sitting here hacking away. If that's what if that's the sort of thing you like to see, then by all means, I'd love to have you stick around. If you were just here to sort of see what SpeedyKnock is and what it does, then I probably won't be discussing, you know, features and that sort of thing a lot more. I'll just be working through the code for now. And clearly my code sucks. So 158, let's have a look. Yeah, okay. Wow, we got something back. That's interesting. Okay, these are pretty much going to be random values, actually, because the... Oh, no, they should be 16, shouldn't they? That's interesting. Well, we got something back at least. Okay, it's calling this over and over. I see what's happening here. We haven't unpiped this correctly. What we need to do here is say, okay, we're finished with this pipe at the moment. Sorry, with the port connection. When we create this parser, we create a new pipe that will feed the parser. When it's finished, we need to actually unpipe it and get rid of all that data. I would take just about anything instead of JavaScript, Connor. It's JavaScript. Look, the idea of JavaScript and what JavaScript was 15 years ago was fine. What it's morphed into is a, wow, abhorrent monster. And I'm a grumpy old man who doesn't like it. How did I learn coding? I did coding at university. It's very different to sort of what I do now. You know, what we did at uni was Java. Whereas I've gotten old and I really like C now. So I think you just practice away at coding, really, and you eventually learn it as you go. For the sake of simplicity, we might just make it send a single byte of data here. Just until we get all of this actually working. That should be fine. Oops. What did we mess up there? at that. It's a really interesting experience, actually, live coding. It adds a weird level of pressure to your coding when you're sitting here and doing dumb things, and it's very conscious that you've got a bunch of people watching over your shoulder as you're doing dumb things. It's a really interesting experience to go through, but I like it. It's quite fun. Assembly, anyone? No, I think I'll pass on that one. Assembly has its place. It's just a weird place. Hey, look at that. We received number of cylinders equals 16. Exactly what we wanted to see. So we should be able to go over here, and our number of cylinders has updated to 16, which is exactly what we wanted, which is terrific. Okay. So we do actually have the two talking properly in terms of config, so that's goodness there. The next step will be going through a couple of different steps here. What do we do? Okay, we'll do this. We'll create another callback here. Receive. Oh man, if I could type. Do I still have the lawnmower running, Speeduino? Sorry, I'm only just catching up on questions here. I do. It's still out there. I haven't pulled it out for a while, but it's all still set up. It's got its tiny weeny little throttle body and everything on it. I just haven't had much need for it. It's somewhat of a sacrilege, but I bought an electric mower, and it works so much better. We'll be lazy and just say. I think it's 17, so let's make it 17. The music's an interesting one because YouTube's so picky about music stuff that it's got its own sort of music library that you can grab that's fully royalty free. I'd really love to be able to just play the music that I normally listen to when I'm coding, but unfortunately it's a little bit restricted about what you can play on these public streams. So this is all just basically from YouTube's music library. So what we're doing is going to say we are looking for a single byte of data. We're going to issue the C2 command, which will return the size of the config. We'll receive that config size, and we're going to set it into our config size variable. We'll unpipe that data, create a new byte, create a new parser that is the size of our config size. So we're just going to have a message here in the log saying requesting config, and we're going to display how many bytes of config we're expecting from the controller. We'll issue the C3 command. And we'll receive it. Now, I suspect this is not going to work at the moment. I think there's something screwy going on with the sizing here, but let's wait and see. Let's run that and see. So we should get a bunch of messages on the log over here saying when we connect. It'll say it's requesting config size. Oh, I've got an error. Oops. I forgot to put that in. Try again. Okay, so it is requesting 17 bytes, so that's okay. We were right with our count. We received the value size from the controller okay. For some reason, well, that's obviously a problem. Can't see why the rest of that wouldn't be working though. Not at a quick glance, at any rate. I think I missed the... There's a very specific time you have to press the reset button. I think I must have missed it. Yeah, I missed it again. Oh no, there we go. I got it. So that all worked. Okay. So we requested 17 bytes. We received something. Okay, so that's actually worked. We've got through that okay. So what we should do then, I guess, is work through setting those values in here. And we can do that relatively easily. We're just going to get what all of these are. Now, some of these might not be, some of the input boxes in the UI probably haven't been set yet. Oh yeah, ignition type has, so that's okay. So we'll just work through these and set their values. Now, if I was doing this really properly, I'd set up some sort of model that defines what data 0, data 1, what the whole struct looks like. And I might do that a little bit later, but for getting things up and running initially, it's going to be fairly quick to, or much quicker just to do it this way. Okay, so we gave all these settings values, which is good, or IDs. We need 8 of these. So if we read these, if we ran this at the moment, we'd basically get random data because there's nothing been set to those configs in the firmware at all. So on the board, they're just junk data. They're probably going to be 255, I suspect, if it's being read out of EEPROM. How much audio can the Typic record? It doesn't really record. what it does is you set a pin on it, low or high, I can't remember. I talked about knock windowing before. So the knock windowing is the window or the duration over which you want to monitor for knock. And the way you do this with the TPIC 8101 is to set a pin state. And I think it's to low. Let's say it's low. So you set that pin state low, and the TPIC will start monitoring, and then you set that pin state high when you want it to stop monitoring. In our case, it's going to be 40 degrees of crankshaft revolution, which might be a few milliseconds, whatever it happens to be, depending on the RPM. And during that time, it doesn't record as such, but it does a constant integration of the knock value that it's receiving from the sensor. So the longer you leave it running, the higher the value integrates, but you need to take that into account with your window size. It gets a little bit complex, the math gets a little bit funky in there, but that's why we have a threshold reading. Oops, what were the rest of the settings? Min RPM and max RPM, might skip those for the moment. I don't know what's going on with this. Duration. Okay, so I've got the knock window and the knock duration. And we need the bore size, don't we? Okay, so we don't actually, the bore size itself doesn't actually get sent to the ECU. What gets sent will be the frequency value here. There is a formula that turns bore size into frequency. I have no idea what it is off the top of my head, but I'll build it into the UI that you enter a value in here, and it automatically spits out a value here in kilohertz, and this will be the value here that gets sent to the ECU. Now, just looking, we don't actually have what the frequency is here. So I'm just going to create another one for what that frequency is. I wonder how big it needs to be. It's been a long time since I've looked at this code. Can't remember where I'm using the frequency here. Okay, yeah, so here, set band pass frequency. So in this case, I've obviously got it hard coded to 7.27 kilohertz, sorry. Okay, so I'll need to do some tweaking here in terms of turning this value from a kilohertz into an actual lookup. Yeah, okay, it's all coming back to me. Yeah, okay, so here we go. You have these, hold on, where is it? You have a table of values from memory that relates to, oh yeah, here we go. that relates to frequency. So I'm going to have to create a table in here that lists all of the knock frequencies. It can't support literally every frequency, but it's got a massive list of frequencies that you can configure it to use. Oh, my memory's failing me. It's been a good 10 months probably since I've looked at any of that TPIC code. Okay, so that's given us a few things. The other one we're going to want is we've already got knock frequency. Okay, so knock frequency will get sent to the device, but we'll read it as well. Okay, sorry, I'm talking to myself here a little bit. Go about your business, it's fine. Cool, okay. All right, we've added a few things there. Let's actually see what happens if we run this bit of code. I'm guessing we're going to receive some fairly random values here. Or we're going to receive an error. It's probably value of null. We got one wrong, did we? 185. Oh, because I didn't save that file. That always helps. Okay, so we just got zeros here, and that's fine too. That's probably to be expected. Interestingly, the knock window delay actually had a value in it, which is interesting. Whatever these values are, they're simply going to have been set from the just whatever default values happen to be in the ECU. So what we might do is now issue a command that goes in the other direction, just so we can actually start updating these. We will do in comms. How will we do this? We'll do it like this. We'll simply start by doing an S command, and we'll make S1 equal to a full send of the config. Basically, we're just going to be doing the reverse of what we just did. Case 1, and we'll say, okay, case 1 is receive a full config dump from UI. Excuse the incredibly messy code layout here. Okay, so really interesting question there from Initial DIY Mods. From my understanding, aren't knock sensors made with certain engine frequencies in mind? Okay, there are two types of knock sensors. There's fixed frequency ones, which are made for, that they're designed for resonance of one frequency only. And that will be the frequency of whatever block or whatever engine they're actually going to be used in. So that's a fixed frequency. There's nothing you can do with those sensors. Or sorry, there's nothing you can do to change the frequency of those sensors. They're designed to work with a specific block, engine block that is. The sensors we're using, that donut style of sensor, are not intended to be used that way. They're simply a resonance, a dumb sensor in effect that will feed the data back, we'll see, God, if I can talk properly, will feed back any signal, whatever the frequency happens to be, and it becomes up to the controller to filter out just to that just to the frequency that we want. And that's what we're doing in the config here. We're saying, okay, here's the bore size of our engine. We use the fancy formula to convert that to whatever the base frequency for knock will be on that size of a bore. And then we configure the TPIC 8101 to say, okay, here's your base knock frequency that we're going to be looking at. And it monitors around that frequency. It's only not specifically that frequency. But that's the two types of sensors that you can have for knock. And this is using the more generic of the sensors, which can be used on virtually any engine, as long as you configure it to look for knock at the correct frequency. So a really good question. If you're looking at using this on an OEM setup, it will depend on whether your OEM setup uses a fixed frequency sensor or one of the more generic ones. Now, most modern cars are using the generic ones rather than a fixed frequency sensor, but you'll need to check what your car happens to be using. Yeah, perfect answer. Bosch wideband sensor is from 3 kilohertz through to 25 kilohertz. Cool. Which is virtually every engine block in that range. And if you looked up the TPIC 8101 datasheet, it would have a set of pre-calibrated frequencies that you can configure it with that would have a similar sort of range from 3 kilohertz through to 25. Like I said, I'm configuring this with 7.27. I obviously, when I did my testing, I obviously calculated that's what I needed for my engine, and I just ran with it. Obviously, as we get further, as I develop this code, it won't be hard coded like that. It'll be set set by the user and then configured on startup. It'll be similar. I mean, it's going to be, it is dependent on the bore size, but you know, most 1.6s, 1.6 or 1.8 engines are going to have similar sorts of bore sizes, and then you're going to end up with similar sorts of frequencies. Okay. Okay, so in this case, we need to wait for a certain amount of data to come through. And the amount of data that we're waiting on is equal to the size of the config. Just get a little bit of dummy data in here. Oh, I just made the same typo 3 times in a row. It's incredible. I'm off to a good Sunday morning. Okay, so all we're going to do is say we're going to monitor the the serial receive buffer, so which is how many bytes of data are currently being received and not read out again. And we're going to monitor that and say just sit there and wait until that buffer size is equal to the size of our config struct. In which case, in this case, it's 17 bytes. So we need to receive 17 bytes from the UI because that's the size of our config struct. So it'll sit there and wait for those 17 bytes to come through. The obvious problem or potential problem in this is that if the UI only sends 16 bytes, then the firmware is going to freeze because it'll just sit there hanging. I'll add some protection in there for that later, but for now it'll get us going. And we really just want to do the opposite of what we were doing before. So, just because that's bugging me. So down here, when we sent the data, we ran through a for loop that read the data out of the config page, wrote it into a temp value, and then sent that temp value. This time, we're just going to do the reverse. We're going to loop through the size of the config struct again, in this case 17, but we're going to go the complete opposite direction. We're going to say we're going to read a byte out from serial, and we will set this pointer value to be temp value. Where did I define temp value? I think I'm going blind. Right there. In fact, I should actually move that because you shouldn't declare variables inside a switch statement. That's bad practice. I'll shove it up there. Okay, when all of that is done, we've received all our values. We need to write them to EEPROM. Now I assume I wrote a function to store the config. It looks like I did. Yep, good job. Put that in the wrong place, didn't I put all the things in the wrong places. All right, I think that's everything. Have I missed anything? So what this will be doing, I've missed a semicolon, that's what I've missed. So we take in, we wait for the, we receive the S1 command, which tells the ECU that, tells the controller that we're going to be receiving a dump of the config. We then wait for the appropriate size of data to come through on the serial buffer. We run through that and we dump it into our config variable, or our config struct, I should say. And then once all of that's done, we write that back to EEPROM. So if we need to, we'll upload that to the board, and then we need to write the UI for sending that data. We've got a couple of messages here. Comparison between side node and side. Yeah, we'll fix that up. Okay. Don't think we've yet got a function for send config. No, we don't. Where will we put it? Okay, I'm basically just going to duplicate this function for now. That's obviously not right. Because it's got the same struct in it that we want to use. Again, we're just going to basically reverse it. So we've got to issue the S1 command first to tell it that we're actually going to be sending the config through. And we'll start sending it through. And really, we're just going to do the opposite of what we're doing. So instead of taking a value from an array that we've received and setting it to a value in the UI, we're going to do the opposite. Now I do wonder whether we're going to need to do any sort of string to number conversion here, but let's crack into it and see whether we get any issues. Does it all make sense what I'm doing here? Sort of going in one direction and then going in the other direction depending on whether we're sending or receiving. It's a bit tedious to work through all of this, but we'll get through it for all these variables. So I might work through this config. If we get the config burning, so we want it received by the controller, we want it burned through to the EEPROM of the controller, I'll then do a reset of the controller and then we'll read the data back out and see whether we got the same value that was actually sent through. If we do that, then I'm going to consider myself pretty happy, and I'll probably wind things up there. My goodness, we've been going nearly 2 hours. I can't believe that. Now we've got to send some dummy values here for the minimum and max RPM. We'll do that in a tick. I do suspect actually that we're going to need to do some sort of data conversion here to make sure we're only sending a single byte, but let's worry about that in a minute. We've just got to send a dummy 4 bytes of data here because I'm not going to pull these two values out yet. $10, $14, $16. We're one short, are we? The knock frequency. Okay, we'll just set them to nothing for now. So, you know, my style of coding here is small steps, right? We're going to do the easy things to make sure that the actual communication back and forward is working, to ensure that the EEPROM burn is working. We reset the unit and get the values back that we expect, and then I'll start filling in the harder stuff later. You know, but small steps, right? Get things working, and then move on to the next step of getting the harder step working. All right, when we need to actually call this function, this send config value, and we'll do that in here. Okay, so this one you can see is calling an update knock frequency function. I suspect that doesn't actually exist. I don't know. No, I suspect it doesn't exist. And that's okay. But this will be the function where we calculate how we turn the bore size into a knock frequency, and then it will call the function to send it. So I obviously had a couple of other functions in mind originally, but I'm just going to wind them all or wrap them all up into a single send config function, and they can all do it then. All just call the same thing. Okay, so every time we change the value in one of these windows or in one of these fields, we should see it calling the send config value. Oops. Yeah, anytime we update these, it should call the send config function, which will then send that data back through to the ECU. We hope. The one thing actually I should have changed here is I'll take this out. So we'll update the number of cylinders value and we'll see what we get back. All right, taking bets. Are we going to get this working first time? I wouldn't take that bet. Whenever you update code where you've got a firmware side and a UI side and you've changed things on both sides, it never works first time. Okay, so this is back to 0 again now. So that's fine because we're not hard coding it. Oh, we've got an error already. Serial type string already. Yeah, okay. I do recall this now. Yeah, okay. So our serial code, the serial library that we're using in JavaScript, yeah, okay. To send binary data, needs to use a buffer. I completely forgot about that. Let's figure out how we do that. Yeah, okay. Right. I did completely forget that. So we create a buffer object. And our buffer will be of size config size. We then write all of these things into that buffer, and then we send the buffer. Yeah, look, modern languages like to make doing simple things hard, in my opinion, and sometimes that's what you want because you want it to take care of a lot of the checks and stuff, and other times you just want to do it yourself and it gets in the way. But anyway. Okay, so instead of writing to the port directly, we're going to have to set all these values into a buffer. And I suspect we're going to need to run a parseInt on them. Okay, so we end up with that instead. Now we can actually ignore this because we don't need to write to those bytes anymore because they'll just be empty in the buffer. And that should be right. 18. Yep. Okay. Let's try again. Yeah, we're just kicking off, Josh. We'll get going in no time at all. Yeah. No, so Josh, I did a run through. Oh, I did a run through initially of SpeedyKnock and just talking about what it is, what it does, how it works. And now I'm just running through updating some code, getting the UI to talk config back to the firmware. And we've got a hang here. So what have we done? That was working a second ago. Why are we hanging now? That's a bit unusual. What did we change? I wonder if we changed the config size, didn't we? We did. I wonder if somewhere I've still got it hard-coded. I bet I do. That's all right. We'll pull that back and we'll see if it's any different. Oops, just realised I've got that hiding under there. Okay, so that worked a bit better this time. We requested the config size. The config size is 17. We received the config from the controller. Okay, good stuff there. So this time what happens? We've still got an error. Where are we? Serial 235. Oh, of course, because we didn't change those, did we? That was a bit dumb of me. Can just comment those out for now. Not needed. How did I make the Speeduino logo on the SpeedyKnock screen? Yeah, I'll show you in a minute. Basically, it's just a big hulking dump of binary data, Connor. See, now I've still got an issue here. Something's hanging. I wonder if I'm not resetting the serial connection properly. Yeah, it's just not talking right. Hold on. You reboot the unit. Suspect I might be putting the unit into a bad state here somewhere. Okay. Oh well, it sent this time with no errors. The controller went crazy. Wow. That's a great error. Oh, it's probably because it's issuing, it thinks it's knocking, so it's flashing white. The camera's not picking it up very well with the frame rate, but basically this is the effect that you get when it's knocking. It flashes black and white very quickly. Okay, well we've sent the data. We've configured it that it should be a 2-cylinder now. Let's reset it, and we'll see if it remembers that it's a 2-cylinder. It didn't. Oh, that's disappointing. So I wonder where it fell apart. nothing obvious there for why it's fallen apart, fallen down. Send the S1 command. We write a buffer. We'll just make sure we're sending this right. Frank, it'll be a standalone unit for the moment. It probably won't have CAN on it, at least in this version. There might be another version down the track, but we'll see. I'll show you where I create that logo in a minute, Connor, if I can remember where I put it. Yeah, so I've just got a big data dump in here, big binary dump. Here it is, yeah. So there you go. Just a great whacking big binary blob of data that makes up the Speeduino logo. It's a bit gratuitous. It eats a lot of memory, but I think it looks cool. Yeah, I mean, you can use it with other ECUs. It just depends what input those ECUs actually expect. Whether they're expecting an analog input or a simple pulse per knock event. Initially, I'm going to work with the pulse per knock event because I think it's a nice system. But I will add an analog output on there as well. Well, that's a bit disappointing. Why hasn't it saved our config, I wonder? Assuming it's received it correctly anyway. I'm assuming that this write config code is actually working. That's a big if. Yeah, that looks okay. Right. And these should be EEPROM updates, by the way, but that's okay. We can change those later. The fact that it went into knock mode makes me think that we might be setting something incorrectly on the controller, because it shouldn't think that it's knocking. Although we're setting a whole bunch of values to some pretty random values, a whole bunch of variables to some pretty random values. So there could be something weird going on there. Yeah, we're setting all our knock thresholds to 0, which won't be helping. Okay. All right, what I'm going to do is just do a bit of a test here. I'm going to set the cylinders to 12. So this is at the end of the serial receive, the config receive section. I'm going to have received the values from the UI. I'm going to override the value that we just received for cylinders, and then I'm going to write that back to config. We then reboot, and we should see 12 if the write config function is actually working. This will at least test whether our write config function is working or not. Can eliminate one source of problems, if nothing else. Okay, so I have to go through this cycle. So I got that to 0. We do it once and it'll send the config. Again, we've got it going into knock mode, which is interesting, but that's okay. This time though, if we restart it, and connect again, we should, if the write config function has worked, we should see the number of cylinders as 12. And we don't. Okay, so I suspect it's something to do with the write config function then is not working correctly, or the read config function for that matter. Well, that'll do it. We're not actually, as far as I can see, we're not actually calling the read config. Yeah, we've disabled that. Okay, that makes sense because, yeah, all right. A lot of some of the values that are in EEPROM then might be screwing with things. All right, let's. Anything could happen here. Let's see what happens when we enable that. Press the button too early. Yep, there we go. Okay, so it does still boot up. I was a bit afraid that enabling that might have actually stopped it from booting, because it could be reading some pretty crazy values out. Hey, so we've got our cylinder count as 12 now. It's fantastic. Let's try. Let's see if any of these others work. We'll set this to 1, 2, 3, 4. Reset it. Hey, and they've been remembered. So it has actually saved these to the EEPROM now, which is terrific. And they've been called back out. So we're successfully sending these config variables through to the controller. The controller is saving those to EEPROM. And when we request them, we're now successfully reading them back from the controller into the UI. So, big success. Everything in terms of the config side there is sending and receiving okay. There's still something very weird going on where when we update these values, the controller itself is thinking that we're going into knock. I'm not quite sure what's going on there, but I'll dig into that and have a bit of a play around and see if I can find what's going on. I suspect it's looking for, yeah, it's going to be grabbing something like the knock window, yeah. Because those are all 0 values, it's going to be doing something weird. Yeah, see, there you go. Right, now we've got a sane knock window. We're actually getting proper values back. Okay, so that was all it was. It was seeing that the knock window duration was set to 0, which is obviously not a valid value. and now it was spazzing out because it was thinking that everything was knock because it had a 0 knock window. So we'll set that to something like 40 degrees, which is about what you'd expect a sane value to be, and we should be good. Cool. How does Speedy Knock compare to the MS3 Knock module? I haven't looked at it closely, if I'm honest. I think they're similar. They're very similar in terms of hardware. I think it's just using the TPIC 8101 as well, which practically everybody uses. But my understanding is that it's simply a hardware module containing that TPIC 8101 on it, and it's doing all of this knock calculation stuff is being done by the Mega Squirt itself. It's not the knock module itself isn't actually doing any of the data processing. It's just feeding the data through to the Mega Squirt, which is doing the calculations itself. That's my understanding anyway. I haven't looked closely at it. So guys, that was really the point I wanted to reach today, and actually get to running with. So I'm probably going to end it there. It's been a pretty long stream, 2 hours and a quarter, 2.25 hours. Hopefully you've all enjoyed it. Hopefully it's been of value to you. I'm going to try and get back into these weekly streams now that I'm not completely crook still. But yeah, that's probably it for this week, I think. Hope you all have a great week. Hopefully that was a good session. And fingers crossed to everyone that we'll see Speedy Knock betas popping up before too long. All right,